thank you all for being here.
Thank you, Adam.
No, thank you. Yeah, you had to be here. Your name's on the slide. So, security obviously has become, and let me know if I get too much feedback here. Security obviously has become very important over the past several years. I don't need to read the news to you. For a long time in security, education and awareness was a big part of what we did in trying to help business units understand risk, but now they see the threats, we see the attacks. And for utilities and private networks, even more so, as critical infrastructure gets called out in government publications and expanding regulations. And so what was at times, I think, buzz terms like zero trust and private telecommunications and things like that are now becoming more necessities and will become more so in the future. And so security also has grown into a multidisciplinary field to where, you know, generalists are less comfortable with dealing with the difference between enterprise security and carrier security, because those are two definitely different worlds to live in there. We talk a lot about the unicorn that exists at the Venn diagram between a utility, telecom, and security, and where those three meet. And so today we will talk about private LTE, but just consider that one network approach. There are other network approaches out there. We're going to talk a bit about how security meets operational efficiency, because we know as business partners and telecom workers and utility workers, the most secure device is the one that's unplugged, turned off, still in the box and in a closet, but you can't operate a network nor a business like that. So we have to wear multiple hats of security as well as business. And we're really in this talk trying to get beyond the philosophy into truly the how. We understand the why. As I said, we see the threats, we know the risk, but now we move into the how. And so, kicking off there, I'd like to ask just the two of you, from a utility perspective, as I just mentioned, we have to wear multiple hats. We have to talk about business operations while still being secure, not being so secure we're inhibiting, but also making sure that we don't destroy security while focusing on operations. So how would you handle operational efficiency when it comes to security?
Sure. So I think one of the interesting questions that are raised around security, is it an investment or is it an expense, right? Because when you invest in something, you get some return in different forms. And if it's just general security, sometimes people look at it as an expense and what am I gaining? And the questions around the effects on operations, and I think we also briefly discussed this morning, are that sometimes you do find security might inhibit operations, but on the other hand, in the world of PLTE, we actually see security aspects increasing the operational efficiency in many ways. If we take it practically to the world of how, if you look at asset management at scale, in hundreds of thousands of devices or millions of devices in the future, how do you actually manage devices both from an inventory perspective, but also from a security perspective? So a lot of security solutions actually give you the ability to manage these devices at scale, reduce a lot of the manual processes of introducing these devices into your network, reduce a lot of, and basically automate a lot of these processes to help you gain more efficiency in many different areas, not just security. So that's one example.
That's a really interesting point there, because the compliance requirements are different, but also as a utility, we have some very unique cases that you're not going to find. We not only have traditional IT, but we have operational technology. We have different threats. We have different threat actors acting on us as critical infrastructure. And so as a utility, when I come to you with these unique challenges, how do you best see us attacking those, or how do you best see us mitigating those kind of unique challenges as trying to secure a utility?
Amazing. So I think the very first thing is no longer looking at your assets as SIM cards. It's the very first, that's the very first step, right? Transitioning from the M&O sort of point of view, or the core point of view of your assets as SIM cards, and looking at the devices themselves. Being able to actually identify the assets, and then if the network identifiers change, if the SIM card is swapped, if the IP is dynamic, you can always still track the device and set those security policies that you're going to set in your network according to the device, regardless of those network identifiers. So that's the very first step, I think, that is inherently to utilities, but to anybody looking to secure their devices in private cellular. And I think the next thing is also gaining visibility that's also unique to this world. It's not just visibility into those devices, their activity, but also to how and where they're communicating from. If I go back to the geofencing example, for that you actually need to know location. You need to be able to visualize and understand where assets are, and you need to be able to do that at scale. So it needs to be manageable also from a bird's eye view, but also enable you to dive into the details, because if something does occur, you need to be able to investigate it. So those are the very first things that are very practical in this world. In addition to all of this, it's also adhering to the best practices of security that are established in your OT networks, in your other IoT networks, or data centers, etc. And these can be things like segmentation, for example. Now, I don't know how many of you have attempted this for private cellular, but we have seen people attempt to do this with APNs, which are very oriented towards quality of service. But is that really the approach that enables enough granularity of segmentation to secure your devices with the use cases mentioned before, such as geofencing? So there are a lot of cases here of, I think people understand the need for security, you understand the need for visibility, for segmentation, and then you take the existing solutions built into what you have, your core, your firewalls, etc., and try to use those for the security best practices that you've adopted in other networks to actually be able to get to that level of security that you're aiming for. And last but not least, I think another aspect is the concept of, I'm going to use the marketing term of single pane of glass here, the ability to see all your assets from a single location. What actually happens in a lot of areas is that you have some visibility tools per each type of device. You've got some meters probably from a certain vendor, that vendor provides you some visibility into that. You have some cellular routers from another vendor, you have some visibility from that vendor into that. But then where do you have a centralized location that gives you the ability to manage all these assets, to actually be able to look at all these devices at scale, thousands, even millions, from a single location to manage them? So it goes back to that single area that of course then connects with the rest of your security solutions to enable you that control. So I think those are a few aspects.
Yeah, from the network side of the equation, I think about the problem in terms of providing visibility and then security policy control. So you need both of those. And what we need to do, on the vendor side here is we have to provide the right information in order to correlate that information so that it's useful, like for one layer, for the device security vendor. And very simply, you can kind of think about it in terms of you want to correlate three pieces of information about that device. You want to correlate what's called the IMEI, which is just the hardware device ID for that. So it's kind of like the device ID for the hardware itself. You want to correlate the IMSI, which is the subscriber information. So this is, your subscriber that you've gotten to the private LTE network, or if you were subscribing to AT&T or, one of the bigger carriers, it would be your subscriber number that you're known by internally. And the device in the cellular world is really known by those two identifiers. And then the third piece of information is the IP address. So whenever a device connects up to the network, just like on a regular network, it's given an IP address that's dynamic. So it's not a static IP address, it's assigned by the network. And that is actually assigned by what's called the cellular core. It's that part of the network there that's running all the software, that's doing the call control and putting everything together. So we'll hand out an IP address there. That IP address changes over time. And if you're using traditional like IP or IT tools like a traditional firewall, that firewall is sitting at the edge of the network and all it sees is the IP address. That's it. So if I'm trying to make sense of it, it's a lot more difficult for me to do that because that IP address is changing over time. So what we provide to the one layer product would be, we're providing that information so that that information can be correlated and put together, so that when you're writing a security policy and you're controlling those endpoints, what you're actually doing is you can see the hardware ID, the subscriber ID, and the IP address, and you can write a nice coherent security policy with that. And from our perspective, we like to do that through standard features that are coming out of that core. So we don't want to do anything, that's proprietary in any way. We want to go ahead and do this in as much of a standards-based way with a standard feature as possible. So we'll provide an event stream going out. That event stream gets processed. And then there's another way, a path coming back into our core when they want to do like a security policy on a particular device. They'll then go ahead and tell our core with a standard API, REST-based API that we're using there, of how to do something, in order to put a security policy on that particular device.
So when you're talking about device visibility, even as a private LTE operator and as a utility, there is the feeling that as long as it's got a SIM card in it, I can see that, I can understand how I can have the visibility there. What about beyond that edge? What about something that plugs into the fixed router? What about something that tethers on the other side of a hotspot, if you will? What is there visibility and control in that?
So that's, again, a wonderful question, because a lot of the areas that we see today, first of all, let's talk about why even cellular routers are introduced into a private cellular network. Usually this happens because you have devices that are not yet cellular ready. Let's say they don't support the SIM cards or cellular, and so but you still want them to operate in your cellular network. You still need them for connectivity. You're not going to replace your whole fleet of devices until a couple of years until devices are there. So cellular routers are introduced as the mediator. They're the adapter. They enable you to connect non-cellular devices to your cellular network. But with this operational efficiency area also is introduced a lot of security risk. You're bringing into your private cellular network risk that comes from the world of traditional IP. And it also causes a blind spot. If you think about it from the cellular network perspective, what you see is the cellular router, or the SIM card within the cellular router, and maybe the modem, but you need to be able to identify this cellular router and what's connected behind it. Now, this is an area where there is a lot of lack of control. It's not inherently built into a cellular network to be able to set this control and visibility, to be able to actually visualize which devices are connected behind the cellular router. Is it a single meter, or should there be a bunch of cameras perhaps connected to the same router? And if it's just this meter, if it's just these cameras, what's preventing someone like a zealous hacker to be able to connect a rogue device to the cellular router? If it's open on Wi-Fi, if it's an Ethernet cable, can somebody just go and plug in an additional device? And what's to prevent someone from doing this? Who gains me the visibility to understand and lock down this device? So a lot of you are probably practicing SIM locks because it's a good security practice for your cellular devices. Are you practicing locks behind your cellular routers? We dub this MAC lock. It's a concept very similar to actually be able to control and set controls on these cellular routers and what should connect behind it. But it all starts with visibility. If you can't actually see what's connected there, how can you possibly control what's connected there? And so these are additional security aspects introduced by an operational aspect of gaining access to devices that are not cellular in your network.
Yeah, it's interesting, from the network perspective, all we see is that cellular router there. It's usually a router, that's connecting there. It's one connection coming back, but there's all these devices there behind it. And the network itself will basically, protect that connection when you're going over the air. So there's encryption that's going on there with very advanced modern algorithms there that's all standards based. So it's going to encrypt that, and it's going to integrity protect that also. And what that means is any bits that go in the device and going over the air, basically there's what's called a hash that's taken on that, and then when you get to the other end, it looks at that hash and it says, yep, I got all those bits over the air, everything was transmitted properly. No one maliciously, or usually, without any malicious intent, tried to actually change those in flight. So that's the only security piece that's there from the network's perspective there, but we don't really see any of the devices behind that. We'll rely on someone like a one layer to be able to get information, on those types of devices. Another way that's often used, in particular in operational technology networks, is sometimes folks will put like a sensor in there, like inside a substation. And that sensor analyzes all the traffic and then talks to some, application that's back at the mothership, usually in the security ops center, looking at what's going on in the substation itself. But for me as the network, that's all transparent to me. That's all moving over the top.
So when we talk about telecommunications networks, the device and the network side of it, how do we bridge that gap from our more traditional existing security tools to dealing with some of these unique threats and risks that we see here specific to telecom? So how do we integrate our existing utility stack, our security stack rather, into these solutions and services?
So I think that also goes back to what Ken mentioned before. So the core, in this case Ericsson, does provide a lot of information about the devices, the IMEI, the MC, the IP, and then of course there's the process of being able to take those network identifiers and reach or an understanding of what is that device that all these different identifiers are actually related to, because these identifiers can change. We mentioned SIM swaps, IP changes, so the identifiers themselves can change, but you always want to be able to look at the device. But then if you look at the IP side solutions or all the traditional security solutions, what they actually see today is the IP from the cellular network. And in most cases it's NATed, because the core actually NATs the IP. Even if we go back to the cellular router example, that IP can also be NATed as well for the devices behind it. So not only might you have one NAT from the core that the IP side sees, but you might have 2, 3, there might be additional different NATs, so eventually the IP side sees the IP side solutions, security solutions, see some network identifier, and they have to be able to trace it back to that original device for actual granular control. If we're thinking segmentation, you do need to be able to create policies of how different assets can communicate, where, who should they be talking to. To actively be able to do this, you need to do this per the device context. So what we're doing here is we actually correlate all these identifiers to enable these IP side solutions the visibility that they need back to that device, no matter how many NATs it goes through, no matter how many different network identifiers change along the way or over time. It's all about these devices. So enrichment of IP side solutions with identifiers of assets is really critical for granular control. To actually be able to leverage and maximize on your existing solutions, you need to give them context. And that's where the collaboration, like something one layer and Ericsson comes into play with enriching firewalls, for example, or IP side OT security solutions, etc., with these identifiers for that granular control. And now with context, you can set policies that make sense. So this is another area of how we increase efficiency, or how you can increase efficiency by leveraging the ecosystem of solutions and not using each solution in a silo, for example.
Yeah, we'll talk about the firewall in a bit coming up, because that's kind of its own discussion there. There's a couple of areas that have kind of popped up in this, melding of the telco and the private enterprise space. One of them is integrating with that security information event management system that's in the SOC. So this is generally, it's Splunk, mostly in utilities, that's what we've seen. A very popular, vendor that's used there. And that's your kind of the central brain where you're sending all this logs and all your other information, and it's processing that data in order to figure out if something's actually gone on, if you've got a breach or something nefarious is actually occurring. So we need to ensure that we're sending the proper logs to that particular device, to that particular system there. So we'll want to look at the logs coming out of the radio network, logs coming off of the transport, the routers themselves, the microwave, or the cell site routers that are there, and then also the logs that are coming out of the core. So the core is running all those applications that are making this network really function, doing all the call control and the processing of the packets. So we'll want to look and make sure that all of that's going out. And this is kind of an interesting area here, and I know your experience, Adam, at Southern Company there along this. Those products like your Splunks of the world, these are very IT-centric primarily. So you've got a lot of out-of-the-box, rule sets and tools. If you're using like Cisco or HP or someone there, you can just download that stuff, and you've got ready-made rule sets that are already pre-built for you. None of that really exists on the telco side, of the equation. So folks like Adam, you've got that's a problem, right?
I was never gray before. No, and that's a great point to talk about. The experience at Southern Link and at Southern Company is Kim is right here, that a lot of traditional security tool sets, again, are built for IT, not even for OT. And if you work in operational technology, you already understand that. It's the same with telco. And so, again, we can gather the information, whether it be device logs or network logs, full packet capture. We can create our tap infrastructure and bring it all home to an aggregation site. But then what? You got a lot of data that Splunk does not understand. You have to write your own queries. And so we've spent a lot of time both operationally creating these use cases and alerts, as well as security-wise, because we need to be able to tell when a site goes down, when something happens operationally in the network, but as well as for certain security use cases, because it's great if they're looking for a brute force attack. That's real simple to recognize, but signaling storms and things like that are a completely different topic there. So we've spent a lot of time doing that. We are going to, I'll segue here in a moment, we're going to talk about our firewalls, but even to creating our tap infrastructure and dealing with our packet aggregators and our full packet capture solution, it's really the same thing. The intelligence that comes out of the box is really IT focused, and so there's a couple of our team members in here today, but my team has really worked tirelessly with our vendors, our support like Ericsson, as well as our own internal company, Southern Link, to try to develop these, and it's not been easy. So we have had some difficulty there making it work for us.
I think that also comes back to the initial topic that we raised around that Venn diagram, right, of knowledge, right? You have utility experts, you have security experts, you have cellular experts. How do you find that unicorn that has all these different aspects and knowledge? And that all on its own is a challenge today. And that, of course, requires training and investment of time. And that's also one of the reasons why we haven't yet seen these playbooks of how to handle this traffic, how to understand these alerts or information that comes from the private cellular network. And it does require knowledge on the other end or some automated processing to give you insights into what you're actually looking at so that you don't have to spend all this time and investment in finding those unicorns or even training them. So it's also about efficiency there. How can we leverage our existing headcount, right? Our existing headcount to gain these insights while slowly closing this gap of knowledge. So this is a huge challenge that we've seen, and that's where I think partnership and collaboration in this industry, which is a unique aspect for utilities, comes into play. The ability to share knowledge between different companies, between different vendors, and collaborate as you build solutions to actually be able to get to the point where you want to be, I think is a utility-focused very important aspect of this domain. It's more collaborative than competitive, which is, I think, an amazing opportunity in the world of security for private cellular.
And we need to use that. Yeah, absolutely.
Yeah, I was just gonna, just an additional comment on that. What we've tried to do too, we've seen kind of these two worlds come together. So Ericsson is really focused on trying to fill some of those gaps. So we've been bringing some solutions to market recently, in particular, to fill, like that log processing problem there. Other things like dealing with things like false base stations and the like. So we're kind of noticing this stuff. We talk to Adam quite a bit. Adam brings up a problem, and we're bringing some solutions to market, in order to kind of fill some of these gaps. Also, you mentioned the full packet capture thing. Also, this is another interesting area there where these two worlds come together. So that that core is made up of what that really is. If you think about it, a modern cellular core is really it's a private cloud that runs on Linux, and it's got a whole pile of servers, and then it's running Linux, and that particular environment is in the process of moving from virtual machines into Linux containers. And that presents interesting problems, in and of itself, because a container is just a process that's isolated on an underlying, Linux operating system. And it uses Kubernetes, to manage all of that stuff there. So in order to meet the requirements, like for full packet capture, we've had to bring certain features, to market in order to deal with that, because you just can't tap that. These are literally containers that can be spinning up across multiple machines. So not only on this machine, it'll spin up over here. How do you tap that interface? So we've had to basically, bring software features called virtual taps that will basically put all of those packet streams together, and then you can point them at your traditional tools in order to have that work.
Yeah, Ken's right. We've come up with problems. It's the double-edged sword of blazing a trail. You end up with bugs in your teeth a lot. But we've talked around it, but I wanted to dig into the specific security tool of the next-gen firewall, because again, one of the struggles we've had is when you talk about behavior heuristics or signatures and things like that. Again, for attacks against telecommunications networks, they don't always exist. So how Southern Company addressed and Southern Link addressed implementing our firewalls, of course, we follow a lot of the security best practices. We moved from an implicit deny to, or explicit deny to, just whitelisting is one way. We've tried our best to work in the context of what we can get out of IDS and IPS, while still trying to, at times, unfortunately, play whack-a-mole with certain things, which happens. But how, in your experience with other customers, how do utilities and other mobile network operators differ, or how are they like with how they implement their security policies at the firewall?
Yeah, that's a very different view if you're a telco versus if you're a utility. So if I'm a telco, they're using a next-gen firewall there, and it's, by the way, it's from the same vendors you're used to using. It's Palo Alto, it's Fortinet, it's Cisco, it's Juniper, it's all the regular folks that you're using, but they're using a different set of software feature sets on those. So it's same vendor, just a little bit of different software and features that they're running. The telco really doesn't care about the higher layer, right? Because remember, they don't care much about the device at all, just the SIM card that's in it. So they're just kind of taking the traffic and they're moving it from A to Z, and that's it. They're not looking at any of the higher level functions that the utility is looking at, kind of that layer 7 functionality and above. In a telco network, the firewall is usually in one of two places. There's one in front of the core, and they call that a security gateway. It's kind of got a defined term in the telco world. And what they're doing there is primarily they're encrypting traffic using standard IPsec encrypted tunnels. And they're only doing that, by the way, when they don't trust their infrastructure. They don't trust their transport. So if you kind of look at a telco, they're kind of a mishmash. And if it's their transport, they won't encrypt over that. But if it's not, then they're going to go ahead and use it. And that tunnel will connect from the RAN node all the way back to the security gateway. And that's really the primary function that they're using it for there. The firewall that goes on the back side, so this is the connection that's coming out of the core and it's connecting into your internal network. There's an interface in the telco world, by the way. They label every interface. So that's called, and I remember probably Adam, you had to go through a learning process, and you really got to memorize those interfaces. Yeah. So they call this the SGI interface. And this is the interface where we're coming out of the telco world and we're given regular IP packets. So it's connecting into the internals of the utility network. The utility will put one there often, and we highly recommend that in order to control traffic that's coming in from the rest of your OT network, to keep that separate, from the cellular side, and just allow the cellular devices only to talk to the right applications in the data center. In the telco world, that usually connects to the wide open internet.
Yeah.
That's never the case in your world, ever, right? So they care about kind of traditional firewall features there, just so a device on the internet can't talk to like a smartphone that's on the AT&T network directly. They care about doing a NAT or network address translation, because it's kind of all private side and then you're going out to the public side, so it's got a route out there. And they also care about denial of service protection there. That's very important to them. Whereas in the inside of your network, not so much, If you got DDoS going on there, that's a really bad day.
Yeah, a RAN side denial of service is a completely different animal. I was shocked. Did you have anything?
Yeah, so I think if we look at it as security best practice, utilities are of course following that, right? You use your firewall as your perimeter security for your private cellular network. That's given its best practice. You should be doing that. It makes total sense. But what happens within, or who's actually guarding what's happening inside your private cellular network? In the world of cellular network, things are routed outside, not all traffic, not in every case. So you do have to have some visibility into what goes on inside, and more so, again, it goes back to that context, right? If you look at your Palos, at your 40s, they're doing what they should be doing for perimeter security, but perhaps not in the most efficient way when they don't have context of what these devices are. It goes back to that concept of IPs that are changing that are natted several times within that private cellular network. You need to give them context. Whoever is setting those policies and managing that Palo needs to be able to understand what groups of devices are they now securing? What policies do I want to set? The easiest way to go about it is to send a very broad policy for a whole segment of IPs, but then you introduce risk. The more granular your policies, the more granular your segmentation, the more your blast radius is reduced in case of an incident, and the more secure you are. And that's the best practice that you're probably practicing in every other network. Then why not in private cellular? So that's the area where context and enriching and the collaboration between Ericsson and OneLayer comes into play as well. The ability to enrich firewalls, the collaboration between all vendors goes back to that. We collaborate with firewall vendors as well to bring a wholesome solution that covers all these different aspects of security, both perimeter and internal to the private cellular network as a whole.
So, first of all, you guys thought this was a talk. This was just a meeting I needed to have. This was an easy way to get to here. So, but you mentioned reducing blast radius, visibility and control, firewalls as perimeter. This is where I'm going to start taking more notes, but how do you see zero trust architectures affecting telecommunications networks or private cellular networks?
Yeah, this is kind of a topic near and dear to my heart. I'm Ericsson's rep on some of the standards bodies, related to this for North America. It's interesting. So zero trust, first of all, kind of just a little explanation of what is this. It's kind of the biggest buzzword now in the cyber world. And it's a way of looking at networks where you fundamentally come from the point that the network is already compromised. So it's a very different way of looking at the security world. And you're implementing a lot more controls, which by the way are just generic controls, because zero trust is an architecture. It's not a vendor solution. It's implementing certain things like encryption and authentication and authorization and making sure that those are, really ubiquitous throughout the whole network. And the U.S. federal government is hell-bent on pushing this stuff down. It's just really a matter of time because they've already, ordered the entire federal government, Department of Defense, to move into this newer way of thinking. Now, this is quite different from the way, for instance, NERC-CIP looks at the world, because NERC-CIP looks at the world in terms of perimeters. You have an electronic security, perimeter, an ESP. So it's like this is a defined area where I'm putting my security controls. And interestingly enough, the telco world has a similar view of the world. So there's a way to basically build security architectures. And the standards-based body is called 3GPP. And there's a document if you want some snooze material there, depending on how you want to look at it. It's an entire security architecture. And in the LTE world, it's called TS 33401. It's kind of our rule book for how these things are put together. And there's a version of that, for 5G also. So they also think in terms of perimeters. It's another way of looking at the world. So if you're Adam here, you have to take 3 models and put them together, and they're not the same. These are not the same models, and it depends who's kind of pushing you. Like Adam, I want zero trust, today. It's not an easy problem really to solve. So you got to kind of look at that and say, okay, what can I do then? And zero trust thinks in terms of what's called a maturity model. And it's a very good concept because no one can really implement this all at once.
No.
So the maturity model does is it breaks down in this CISA, the security agency for the federal government, has put out a nice document actually on this. The maturity model, it's version 2.0, where it will tell you, this is where you start, these are the types of things you're going to do, and then here's your intermediate stage, and then here's your advanced stage. And you can kind of go from one to another. And looking at that, I have a task to put that together for the private LTE world. So I'm kind of working on that right now. And, I would recommend kind of looking at things like your management plan. Look at that, where the humans are interacting, and then overlay something that can do like multi-factor authentication, on top of that. Look to do that. That's a really good one to do because a lot of the existing features for encryption and integrity and authentication authorization, they're actually already there, within the network. So you're kind of looking where to fill those gaps, and what to do with that. I would look at the device side, and then I'd also look at where can I do encryption potentially in areas of the network that I'm not doing it.
Right.
And this becomes really an internal discussion. It's like you own, like the utility owns its internal MPLS backbone. They don't necessarily, they're kind of like the telcos. They're not going to encrypt over that. But if you're going to move to a zero trust world, you got to look at encrypting some of that stuff there, like the signaling, for instance, between the RAN and the core, that's going over the clear, across that backbone. So you kind of look at areas like that.
Wow.
I'm gonna add to it because I think there were a few things mentioned here that are spot on. So if we think multi-factor authentication or even just 2FA, right? You can think cellular, right? Think about the concept of the SIM authenticates the core authenticates the SIM. But I think we've established that's not only what we see in private cellular networks. You do have, for example, the cellular routers, everything behind them. Do those adhere to your zero trust concept of multi-factor authentication? Those are another set of questions that you probably need to ask yourself when trying to take the zero trust concept and bringing it into like your day-to-day best security practices for your network. As you map your gaps, as you establish where do I have some 2FA or multi-factor set, where am I lacking multi-factor? So it's about also mapping those risks to understand which areas adhere to this concept of trust nothing except what you specifically allowed, which areas still introduce this risk. And again, encryption is really critical in the world of cellular. You also have to be able, though, to look into what's happening in the traffic with solutions, because encryption does the wonderful job of masking things, but it also inhibits and actually creates some challenges when you need to investigate and drill down to a source of, be it a threat or a misconfiguration. So you have to have both abilities. You need to adhere to these regulations of security and still be able to drill down into the aspect. So it goes back to what Ken mentioned. These are all best practices, and I think the best way to go about it in your private cellular network is to map those gaps initially. Of course, following the maturity model. Where do I start? Do I start with authorization, authentication, 2FA? What are my risks there? Is it behind my cellular router, or is it within the devices and my lack of visibility to them? Is it between my core to my RAN? So there's a lot of different questions there as to where would be the best place to start. What have I already done? What are my gaps still? And then start to move forward into bridging those gaps. Of course, not waking up in the morning, everything is fixed. It's a process. It takes a while. But prioritizing and starting with that is probably the best.
Yeah, absolutely. I think when you think of zero trust, assume breach is what you'll hear a lot. And then, of course, just the change in mindset that there is no longer a perimeter where things are safe behind it. I also will tout the CISA maturity model. It is a great reading and a step in that journey. The NIST special publication on zero trust architecture is great, but it will diminish your spirits if you try to read it all. take it all at its own. But I think CISA does a great job with its traditional to initial and advanced on up to optimal. So we are getting close to the end of our time. I wanted to thank Avishad from One Layer and Ken from Ericsson. Are there any